code. If you are planning on attending or thinking about attending, I highly recommend it. Lots of people from all over the world come to this. It's an excellent event. Lots of learning, lots of knowledge, lots of sharing, lots of networking. I have lots of great friends that have come out of this event. And our schedule for today, which we are slowly going through, Tim Mitchell, we're up at 3 with only 2 following this. Looking forward to the day. So Tim, I'm going to go ahead and change it right over to you so you can get started, because I know everybody's super eager to hear about SSIS today. And off to you.
Let me reshare my monitor. I'll make sure before you drop off, Leslie, that you're able to see that okay. You should be able to see once it started my PowerPoint presentation.
It is up. Yep.
All right. All right, so thanks, Leslie, and thanks to everyone on the past Performance Virtual chapter that made this happen. This is it's either the 2nd or 3rd annual event that they're doing this on the Performance Palooza. Always a good time, and they're really having a lot more people register this year than they did in the years past. So definitely glad to see them doing this, and certainly honored to be a part of it. So I think most of the presentations have been cycled around the database engine itself and performance around that. We'll break away just a little bit. We're going to talk about performance and integration services, and I'll share with you some of the tips that I've learned in working through integration services and troubleshooting and developing performance or high-performing integration services packages. So by way of agenda, we'll start off, I'll talk a little bit about performance, and I mentioned SSIS performance. We'll talk about performance in general as a concept. We'll jump into some troubleshooting methods specific to integration services. And then I've got quite a few rapid-fire tips that I'll throw at you that can help you develop better performing and better performing SSIS packages that are optimally designed for scalability and things like that. So just a little about me. Again, my name is Tim Mitchell. I'm a BI consultant. I've been working with SQL Server for about 12 years now. I've been in the BI space for almost 10 years of that. Work with a company called Lynchpin People. I'm a partner with Lynchpin. We focus on the BI side, on reporting analytics. We do quite a bit in the ETL space and in the performance space as well in database health and wellness. I'm a SQL Server MVP. You can follow my various online activities. I blog at timmitchell.net, and if you're on Twitter, I'm at Tim_Mitchell, and I've got my email address up there as well. You can see along the bottom a couple things that I've participated in, including the SSIS Integration Services Design Patterns book. We just released an update to that earlier this year, as well as the MVP Deep Dives Volume 2. Just a couple of housekeeping items. As Leslie mentioned, we've got right about an hour worth of material and an hour of time. So what I'll do is if you have questions that come up during the presentation, go ahead and put them in the queue. Leslie will be moderating those, and then toward the end, depending on how much time we have, we'll try to address some of those questions. We've got, it looks like a little over 200 people in the presentation, so I'm certain we won't get all the questions. But I will put up my email address again. If something comes up that I don't get a chance to answer, feel free to email me about that. And everything you see with the slide deck, I will have that on my website. I believe that the virtual chapter puts that on their website as well, but I'll certainly have it on mine. One item that I don't have on there, and I normally do this presentation in person. If you hear barking in the background, that's going to be my office assistant, so pay no attention. I haven't morphed into an animal or anything if you hear barking. All right, let's talk a little bit about performance as a concept. So when we think about running an integration services package, or really any ETL process at all, 2 questions come up. The first and foremost question is, did it succeed? Did we get a red box or a green box? Or if you're using a later version, did we get a green check mark or a big red X going through it? That's the key question as far as the success metric. But followed closely behind that is, how long did the package run? Does it normally run for an hour and it ran for a minute this time, or the opposite? Does it normally run for a minute and it run for an hour? Even though that doesn't necessarily indicate a success or failure of the process, that's one of the metrics that we look at when we're analyzing what goes on in an integration services package. Why is performance important? The answer is it may not always be, and I'll talk a little more about that in just a bit, but we have to pay attention to performance because there are people and processes that are depending on the data that we're sending out. I may have processes stacked on top of processes. I may have users that are depending on the data to be available at 7 a.m. or 8 a.m. And making sure that my processes run in a timely manner is critical to getting the data where it needs to be at the appropriate time. Very often you'll only have a limited amount of time that you can run your processes. So if you've got, say, a 2-hour maintenance window, 4-hour maintenance window, or whatever that turns out to be, your ETL processes have to fit within that window. Otherwise, you're breaking your SLAs or you're impacting other performance or other processes that are depending on that data. Just a little backstory on that. Before I got into consulting, I worked for a school district, followed by a job at a hospital. When you talk about loading and maintenance windows, those are about as far apart as two environments can be. When I was at the school district, quite literally, I could shut down the data center at 5:30, and hardly anyone would know the difference as long as I had it back up by 6 a.m. the next day. By contrast, working for a hospital, you've got to have the systems available. By and large, all your systems have to be available 24/7. So coming out of that environment, making sure that all my ETL processes were performing in a timely manner was much more critical because I was working in a 24/7 environment. And also I alluded to potentially overlapping cycles. So if you've got process A that runs for an hour, process B that runs for an hour, and it's dependent on the results of process A, you can't have those two overlapping. They have to be run serially, and you do have to pay attention to performance on that. But the most important concern, we want to be able to brag how quickly we're loading data. I loaded a terabyte of data in N number of hours, or whatever the case may be. And that one's a little bit silly, but we do like to be able to say that we loaded this amount of data in this amount of time. And it does have, apart from the bragging piece, it does have some tangible benefits as well. So let's talk specifically about integration services. So when we're troubleshooting integration services, the first question we have to answer is, do we really care about performance? I just rolled off of a client engagement some time back where they had a process that would run every month. So it ran as soon as a data file came in, and it would run for about 15 minutes or so. It had several steps that it would do the stage of the data and then do some transformations along the wire. I'm quite certain that I could have cut that performance runtime down at least in half, if not just a fraction of that time. But the fact that that process runs exactly once a month and it doesn't really impact a lot of other processes, and it doesn't run for days and days at a time. While I could have improved the performance of that package, there wasn't a lot of business value in doing so. So in a case like that, as much as I wanted to do some tweaking on this package that I inherited, there wasn't really a sufficient business case to be able to do that. So performance may not be a concern. If performance is a concern, you have to ask the question, is SSIS really the culprit? Very often the answer is no. If you have a slowly running process and you've got a package that kicks everything off, the natural assumption is that something in the package is running slowly, but very often the case is it doesn't have anything to do with SSIS itself. It's the source, the destination, something along those lines, and not really a package tweak that needs to be made. Now, assuming it is an integration services issue, it's not enough to say the package is running slowly. You have to get down and drill down to the specific task or on the data flow of the component that's causing the issue before you can really do any troubleshooting. Otherwise, you're just throwing stuff at the wall to see what sticks. So if it is an SSIS issue, in some cases you can test outside of the scope of SSIS. If you're just running, let's say, a SQL statement via an SQL, execute SQL command, that's really easy to pick up out of integration services, drop it over into a Management Studio window, and do the test run over there and see if it really is an SSIS problem, and then compare those results. If you get about the same result, then possibly it's something within that script that you're running as opposed to being a deficiency in integration services. Within integration services, this is something that I don't think anybody really likes to hear about, logging. It's not one of my favorite topics to talk about, but I allude to this being the foundation of the house. So if you're looking for a new house, you're going to buy a house, nobody ever pulls up out front and says, wow, look at that foundation, it's beautiful. But if the foundation is not built properly, you will absolutely know it because your house is going to fall down around you. Logging is the foundation of that house, and you have to be able to know what's occurred in the past to know what's normal and what should happen in the future. So for a lot of different reasons, you want to make sure that you're logging, but in particular on analyzing your performance, you have to be logging information. There's a couple of different ways that you can do that in integration services on any version of SSIS. You can use the native package logging. I call this legacy logging because it's no longer the preferred way to do logging in SSIS. If you're using SSIS 2012 or later, you can use the SSIS catalog to do your logging. It's a much, much easier way to do logging. Doesn't give you as many options. It's not quite as configurable, but it is a really easy way, and quite literally it's just a single drop-down list that you can specify how you want to log your package. And if you want to really, really get specific about the information that you're logging, you can create your own custom logging routine as well using stored procedures or C# or whatever you write in. Whatever it looks like, it doesn't really matter what type of logging you do. When you're analyzing performance on your packages, you have to be doing some sort of logging so you can capture that information. So this is a sample output. Don't worry so much about the query itself, but if you look at, and this is coming from the SSIS catalog, so this is on either 2012 or 2014, this query will work, and it will give you the information like what the package name is, the individual task, the component within that task, and when it started and ended. You can break down to, in fact, and I'm not sure if my mouse is going to show up on the PowerPoint here, but you can even get into, once you're into the component name, you can see what phase it was. So if it takes, if this derived column takes 10 minutes to run, I can break it down by piece and figure out which phase is causing the issue. And SSIS in 2012 and 14 will natively give me that information, but even if I'm not using 2012 or 14, I can write some queries and build my logging in such a way that I can get this type of output. So if you're not doing logging, or if you want to supplement your logging, you can do what I call brute force troubleshooting, figuring out where your problem is by taking away a piece at a time and seeing how it impacts your performance. This is much easier to do on the control flow side because you can simply disable a task, see if the package runs more quickly without that, or the inverse of that is you can run task by task and see how long each of those pieces is running. It's a little more difficult over on the data flow side because you can't disable a component. You actually have to remove the component entirely. But if you're using SSIS 2012 or 14, you'll remember that you now have undo and redo support. So it's much easier to go back, take out the piece that you want to test without, run it, and then go through the undo operation as opposed to restoring the file from backup and put it back in. So things to look for, and these are roughly in order of how you're going to experience them in integration services. Disk I/O and memory are generally your two biggest culprits when you're talking about integration services packages. Disk I/O is becoming a little bit less of an issue in the age of SSDs, but it's still, I still see quite a few bottlenecks even on SSD-enabled systems. Memory, if you're pushing a lot of data through, to some extent, depending on the operation that you're doing, CPU and network can be a concern. But in my experience with integration services packages, those are less of an issue than disk I/O and memory. All right, so that's a discussion of performance at a high level. So let's talk specifically about some of the tips that I've run across or that I've built up on dealing with integration services. So I briefly touched on this earlier. Look at the way that your sources and destinations are configured. Most of your problems don't reside within the processing of integration services. Most of them are kind of what I call on the bookend. So it's on either end of integration services, either getting data into SSIS or sending data out somewhere else once SSIS is done with it. So that's not to say that you can't develop a poorly performing integration services. You can. I've seen a lot of them. I've done a few of them myself. But if you're looking at performance, make sure that you're not assuming that something is broken or misconfigured in integration services. So looking at things like the way that you're retrieving data. I'll talk a little bit more about how you pull data in specifically on the data flow. But look at your queries. Make sure that you're writing good queries, that you're writing sargable queries. You probably heard, I'm assuming that you've heard that phrase at least at some point, if not before today, certainly on probably a couple of occasions today during other discussions about performance. But writing a good sargable query within your source to make sure that you're getting data back as quickly as possible will be a big help. Knowing how your tables are indexed, and then knowing how network speed and latency and as I mentioned earlier, disk I/O can impact how quickly you're getting data back out. All right, tip number 2, using option fast end. So this really isn't an SSIS trick, but this is really handy within the context of SSIS. I've got a link at the end of the PowerPoint slide deck. This was mentioned by a friend of mine named Rob Farley a couple of years ago in a blog post that he wrote, and I've got the link to the blog post in my notes. This is a T-SQL option or a query hint that will suggest to the database engine that I want you to return this information, but I want to get n number of results as quickly as possible. And that n is whatever number I specify. So fast 1,000, fast 10,000. And you can see the syntax up here where I put it at the end of the query as an option. I do want to call out that this is not intended to make the whole query faster. It may make it a little bit faster, but there are cases where I've seen option fast n actually make the query a little bit slower. What you're trying to do here is to get integration services at the data as quickly as possible, not necessarily improve the overall query, the overall time of the query. So that might not make sense initially, but if you think about how integration services processes data. So if you're pulling in data from a SQL Server source, you've got a query and it takes, let's say, 2 minutes to start getting the results. And that's, imagine that we're on a timeline here. And this timeline on the left, or this block on the left is the amount of time that it takes to get the data out of integration or out of SQL Server into integration services. Once that data starts coming in, at that point, integration services can start processing the data. But in this space, and again, I'm not certain that my mouse is showing up, but to the left of that yellow box there, what integration services is doing while it's waiting for data is absolutely nothing. It's sitting there waiting. It can't address any of the data that's coming through, so it can't do anything at all. And then once we've got the data processed in integration services, we'll have some amount of time that we loaded out to the destination. And this is, again, a timeline what might occur if you're not using option fast n. If you are using option fast n, generally speaking, the individual pieces of the package aren't intended to run any faster, but here's what happens. Whenever we use option fast n, the overlap time actually increases. The amount of time that those pieces overlap will increase. So instead of waiting until about the 90% mark to start getting data, you can see on this timeline the processing time in integration services packages is about the same, but it's actually occurring earlier in the life cycle. So even though individually these pieces aren't running any faster, because they're overlapping to a greater degree, your package will in effect run a little bit faster. Now, this isn't a silver bullet solution. In fact, nothing I'll discuss today will be a silver bullet solution. And in a package like this, where you've got a really simple package where you've got a source, a derived column transformation, and a destination, it's probably not going to help out much at all because your data is not spending a whole lot of time in your data flow. A package where that might be beneficial is something that looks more like this, where you know your data is going to spend a little time in the data flow. It's going to do some processing. Maybe you've got some partially or fully blocking transformations. We'll talk about those in just a bit. Maybe you've got some transformations that are blocking or causing some slowdowns. The key here is not necessarily to get your source query running faster in itself. The key is to get the data to integration services as quickly as possible. So using that option fast n can be a good option to try to help out with that. All right, so tip number 3, I mentioned just a minute ago the blocking properties of transformations. Every transformation that operates on the data flow will be categorized in one of 3 ways, either non-blocking, partially blocking, or fully blocking. So the way those work is a non-blocking transformation, just like the name implies, it doesn't hold anything up. So think about the row count, the derived column transformation, for example. As quickly as it's getting data in, it's applying whatever transformation you have specified and sending it back out the other side. It doesn't have any need to hold that data at all. It's a green light, passes data straight through. One thing I will mention is the conditional split. We could probably spend a half an hour just talking about this, but when you're talking about memory management in the conditional split, when you branch out data and send, say you've got a pipeline of a million rows of data, you send half of it to destination A, half to destination B. It doesn't really make a copy of the data. It's kind of a virtual copy. So the conditional split, even though it looks like it might be a little bit of a slower transformation, it's actually just creating a virtual copy. So it's grouped in with the non-blocking transformations. The partially blocking transforms will hold buffers as needed to process data. So for those of you who have used the merge join, not my favorite transformation, but it is useful in a couple of different cases. The merge join, the way that it works is it expects data to be sorted from the left and the right input, and it can't pass in the data from the A's, the B's, and the C's because it's working it in order from the left side until it gets all the A or B or C data from the right side. So it can hold buffers as needed. The lookup transformation, if you look on Microsoft's website and look up the blocking properties of transformations, Microsoft documentation actually disagrees with me on this. Microsoft classifies the lookup transformation as a non-blocking transformation. And to the strictest definition of the phrase, I will agree with that. The reason I like to group this in with a partially blocking transformation is that the lookup transformation, when you use the default settings, the first thing it's going to do before it processes any data whatsoever, it's going to go out to the table that you specify, pull in all that data into SSIS memory before it processes a single row of data. So yes, it is true that it doesn't hold buffers, but it still causes a delay. I won't say a brief delay. Hopefully it's usually a brief delay, but it does cause a delay in your package for the amount of time it takes to go out, pull that information in, and write it to integration services memory. And to some extent, the union all can be partially blocking. I've not seen a lot of performance issues on the union all, but technically that's categorized as a partially blocking transformation as well. And now our fully blocking transformations. These are the red lights. Everything stops until all the data is received. So think of this as, so on the non-blocking or partially blocking, think of it as a bucket brigade where you're passing the bucket along. As soon as you get the bucket of water, you pass it to the person next to you. The fully blocking transformations, they will hold everything. Effectively, all those buckets will queue up at one station or at one transformation until they're all received. And you can look at the names that I've included there. So I included the sort, the aggregate, your fuzzy tools. Just because of the nature of what they do, obviously you can't sort all the data until you get all the data. You can't calculate a min, a max, an average, or any other aggregate until you have all the data in that particular buffer or that particular transformation. So it will block and hold all the data at that point before it passes it through. Now, I do want to call out that even though we call these fully blocking transformations, and I'm putting up a couple of warnings about using them, they're not evil. Every tool has its job, and I've used all the tools that we talked about. I've used the sort transformation. I've used every one of these that we've talked about. I don't use them liberally, especially when we're talking about the fully blocking transformations, because they can cause performance issues, and in some cases there are better ways to address things like sorting and aggregations. But where they're appropriate, in cases where if I'm dealing with non-relational data, if I'm dealing with a very small set of data, very often those can be good solutions. So it's not an everyday kind of use tool, but it's not evil either. So use them where you need to use them, but just keep them in your hip pocket and know that they are there. All right, I was going to show a demo on the blocking transformations. It was kind of a light demo anyway, so I'm going to skip past that to make sure that I've got a couple of other demos that I really want to show. Let's talk a little more about, we'll talk slow transformations this time. So this isn't, I'm not going to talk about the blocking properties here, but there are some transformations that they're not fully blocking transformations, but just by nature of what they do, they tend to be slower than other transformations. So generally I'll ask when I do this presentation in person, I'll ask for a show of hands of who all has used the slowly changing dimension wizard. And I'll get maybe 20% of the people will raise their hand. I'll say leave your hand up if that's been a positive experience, and maybe one person in the room will ever leave their hand up. The slowly changing dimension wizard, that is a really, really specific tool in integration services, and if you're not familiar with data warehousing technologies or terminologies, a slowly changing dimension is a way that I can keep track of history or keep track of information that supplements my facts, my sales information, my cash register, whatever facts I'm tracking. And I can apply a slowly changing dimension pattern, either keeping history, discarding history, or whatnot. And there is a wizard in integration services that will walk me through and identify how I want to join that data together, what type of history, if any, I want to keep, and so on. It's a really good tool for getting started with slowly changing dimensions. It's a really bad tool if you've got anything larger than maybe a few hundred, a few thousand rows at most, because it simply does not scale. The OLEDB command is a similar tool in that I have used the OLEDB command from time to time. It does allow me, and I've got toward the end, I've actually got a demo of the OLEDB command. So essentially what both of these tools are doing, they're doing row by row operations. By default, integration services wants to do everything in a set-based operation, just like the database engine does. These tools, because they are specialty tools, they're breaking down to not doing an entire set or an entire bulk operation, but doing processing on a row by row basis. While that does allow you a lot of flexibility, you also pay for it in terms of performance. So I won't tell you not to use those tools, just like I talked about the fully blocking transformations. I won't say never use those. So I'll go back a slide. I know I've used the OLEDB command several times. I don't think I've ever had a successful deployment of the slowly changing dimension wizard. I know there are those that have, and in some circumstances it has worked well. So I won't tell you never to use it, but these are really, really specialized tools. Know that they're there, and know that they are accessible for row by row operations, but do know the performance penalty that you can pay if you are using those tools. All right, number 5. When you're using relational sources, in particular your OLEDB source, you know that there's a really handy tool, and I thought I had a screenshot, I do not. There's a really handy tool that will allow you to use a drop-down list and get a list of tables on that relational database that you're connecting to and say, I want to get all the rows from customers or sales or lodging locations or whatever it is I'm tracking. And it does a really good job of showing me all the tables that I have on there. The downside is that it's a poorly performing operation for 2 different reasons. First of all, every time you use the table list, the drop-down list, you're doing a select star from. Now, you might need all those columns, but chances are you probably don't. So a better option is to, say, write your query and do select column 1, column 2, column 3, whatever columns you need, and put those columns in there. Yes, it is extra work. Yes, you do have to look up the table structure in most cases just to make sure that you've got the right columns, you're spelling the column names right, and so on. But it does perform better in most cases. One thing I have noticed is that if you use that table drop-down list, it doesn't go out and say directly select star from that table. It actually does an open row set operation and incurs an additional penalty to retrieve that metadata. So it's got to go out and get the metadata using an open row set, and then it can do its select star from. This adds a little bit of performance dent on a table, especially if you're using views. You will notice the performance difference. And hopefully you don't have this design, but if you've got nested views where you have a view calling a view, I've seen the performance time go from quite literally a fraction of a second to 10 or 15 seconds if you're doing the table list as opposed to select column list from. So this is a rule that unfortunately I find myself breaking, especially when I do demos, but because it is really handy to pull down, use that table drop-down list. But you can see some performance benefit by taking that out and writing your query in the window. And one additional benefit, this isn't really a technical benefit, but it can be a little bit of a reminder that, hey, I don't need all the data. I need to only get my active customers or my sales from last night as opposed to all the sales. So it can be a little bit of a mental reminder that, hey, I can throw in a where clause, cut down on the number of rows that I'm processing, and therefore speed up the overall package as well. All right, tip number 6, running in optimized mode. So I'll only spend just a second talking about this because this is the default setting for the data flow, but there is a setting called run in optimized mode that will attempt to, and I want to emphasize attempt to, suppress the allocation of memory if you're not using a column further downstream. So referring to the previous slide that I had, pardon me, if you're bringing in 35 columns and you're only using 10 of them, what run in optimized mode will attempt to do is say, I see that you're bringing in 35 columns, you're only using 10 of them, so I'm not going to, the SSIS engine is not going to reserve memory for those extra 25 columns. Now, it doesn't always work that way because it may not be able to automatically detect which columns you're using and which ones you're not. But this is a setting that you want to make sure that you are using. Again, it is the default unless you go in and set this to run in optimized mode. Unless you set that to the non-default value of false, it should already be set that way. And I do want to point out that if you pay attention to the warnings that you get, and hopefully you are, you will still see that warning that you've got column X, column Y, column Z in your data flow that you're not subsequently using downstream. So it will not, run in optimized mode will not suppress that warning. It will still pop up. All right, number 7, when you can, transform your data before you get it into integration services. If you've heard me present before, you've heard me say this phrase, let the database engine do what it does well. I should get a tattoo with that on there because I'm a big fan of using the right tool for the right job. And even though I'm an SSIS guy, I really dig if it's a database engine operation, if I'm doing sorting, if I'm doing a bunch of lookups. Very often I can do that in the source and not my relational source, even if it's not SQL Server, if it's Oracle, DB2, wherever I'm pulling that data from. If I can do some of that transformation in the source, I can save a lot of pain and a lot of extra performance on the integration services side. So operations, especially like if I'm doing a sort, if you're pulling data, I rarely say never, but I can't imagine a circumstance where you would want to pull data from a relational source, a source that's capable of sorting the data, and then explicitly sort it in integration services. 99 times out of 100, probably even 999 times out of 1,000, a sort operation in the relational engine, any relational engine, will outperform integration services sorting that data because that's what the database engine does well. Even thinking about lookups and joins. So if I'm doing, and this reminds me of the first package that I ever did, lookups and joins very often are better done in the database engine. The first package I ever built, it had a ton of data flows. It was a big behemoth of a package. It was literally 5 megs of XML data alone. That was just the metadata. But what I ended up doing was I connected to my source and then I needed to join like 8 or 10 or 12 tables. Rather than simply doing the join in the relational engine in the source, I pulled in the data that I needed and then did a lookup transformation to join table 1, a lookup transformation to join table 2, and on and on and on for all the tables that I needed. That worked and it got the job done. It would almost certainly have performed better if I would have done all those joins within the relational database engine because I'm letting the database engine do what it does well. So again, that certainly aggregates will almost always outperform, the database engine will almost always outperform integration services on those. All right, number 8, paying attention to your concurrent executables. This is a package level setting and I can specify how many pieces within a single package can be running at once. Most of us, especially if we're dealing with a server with a lot of cores, a lot of CPU cores, probably never ran into this before. But as we start to virtualize more and more, and in fact I'm running this demo on a virtual machine, we actually have, in many cases, fewer logical processors than we have physical processors. So this can be a bit of an issue. The default setting on the maximum concurrent executables is -1, which means that it's going to take whatever number of logical processors that machine has and add 2 to it. So in this case, I've got on this machine, I've got 2 logical processors. The default maximum concurrent executables will be 4. So again, this may not be a big issue in a lot of cases, but if you're dealing with a machine that has a small number of logical cores in your processor, it can be an issue. And I'm going to show you a quick demo to flesh that out and show you how that works. So in here I've got 10 different script tasks, and each one of them is just going to run for a few seconds and then succeed. And if I look over on my package properties, if I hit F4 to bring up my package properties window, the property that we're looking at is, again, this is at the package level, max concurrent executables. It is set to the default value of -1. Again, with this machine having 2 logical processors available to it, when I run this, even though I have no constraints on those, you can see that I'll only start 4 tasks at any given time. And then when those finish, the next 4 will spin up. Once those 4 finish, the following 2 will finish or will start, and they'll run for just a bit and finish up. So you can see that with that setting, it will only, within the scope of this package, it will only allow that number of concurrent executables to run at any given time. So let's override that just to prove out that that's really what happens. Let's change that to, so I've got 10, let's change that to 9 just for fun. So setting that from the default of -1, I'm going to set that to 9. I'm going to rerun my package. And now what should happen is that I'm going to get exactly 9 script tasks running at once. You can see that the 10th one up here is not running, but once one of these completes, you can see that that one kicks off. Now, it is important to note that this only governs within that particular package how many executables can be running. If I have 50 packages running at once, each package will independently define how many executables it can have running at any given time. And again, if you're dealing with a machine that has lots of logical processors available to you, or if you design integrations to try to keep the packages relatively small and each one only does 1 or 2 things, it probably won't be a big deal. But if you do have a package that runs a lot of different pieces at one time, you want to pay attention to this setting. All right, so tip number 9, make sure that you're paying attention to parallelism. So I think we're wired as humans just to think serially. I need to make a trip to the grocery store. I'm going to get in my car. That's number 1. I'm going to drive to the grocery store. That's number 2. I'm going to go down the bread aisle. So we do things in order like that. Integration services isn't governed like that. It can, to the extent that the hardware will allow and the business logic will allow, I can run multiple pieces at any given time. So you do have to know, obviously you have to know the limits of your machine, how much memory you have, how much I/O throughput you have. You definitely need to pay attention to any sort of constraints. If I've got task 1 and task 2, if task 2 is dependent on the successful execution of task 1, I can't run them in parallel. But if they are completely independent operations and one doesn't depend on the other, I can run those as parallel operations. This is one of the things I always like to tell you. Any advice that you hear from me or anybody else, make sure that you test it. It's as important to test going parallel as any other piece of advice you'll ever hear on integration services performance. Because if you set everything to run at one time, I promise your performance will not improve, it will degrade. Because you're going to run out of memory, you're going to run out of I/O throughput or some other metric that you need. So you have to exhaustively test this. Don't go and change all your packages from running in serial to running in parallel. It takes a light touch, and it's not something that you can do simply overnight. You have to go through some testing cycles to make sure that it works like you intend. All right, tip number 10, don't be afraid to rebel. So I'm an SSIS guy. For the better part of the last 10 years, I've made my living using this product and doing ETL and data quality in various operations. But integration services is not the only game in town. So there's a lot of solutions that integration services, while it can solve every problem that I found, it's not always the best solution for the problem. I always like to say if all you have is a hammer, if the only tool that you have is a hammer, every problem looks like a nail. That was the folly that I fell into when I first started using integration services. That was my tool. That was my hammer. And I solved almost every problem, whether it was an ETL problem or not. I solved almost every problem with integration services. There are tools either kind of on the fringes or even completely outside integration services that can be a better solution. Things like using the merge statement in T-SQL. So I talked a little bit earlier about the slowly changing dimension wizard and the fact that I don't really like that. If I'm doing a slowly changing dimension load, 9 times out of 10, I'm using the T-SQL merge statement. Now, I'm calling it from integration services, but I'm not using the native tools in SSIS because, frankly, the merge statement is going to outperform and it's going to be easier to understand than using those native tools once you've gotten accustomed to it. Using native T-SQL tools like insert select, sometimes third-party components, or even outside pieces outside of integration services can be a benefit there. So I'm not telling you not to use integration services. Don't hear me saying that. But do know that there are some other tools, especially when you talk about performance, that in some cases may outperform integration services. All right, tip number 11, pay attention to what you're spooling out to your disk. So the worst thing you can do in integration services on the data flow is to take data from physical RAM and write it out to a disk, because that's going to be, even in the land of SSDs, writing that information out to a physical disk will still be much slower than keeping that information in memory. There is a particular counter that you can look for that will indicate this kind of memory pressure. It's under perfmon, under SSIS buffer spooled. And if you look here, depending on what version you've got, so I've got, this screenshot was from 2012. If you're on 2014, it'll say a pipeline 12.0. But look for buffer spooled and add that into your perfmon counters. Ideally, that number should be 0. Anything above 0, you ought to be investigating and figure out why it is you're spooling the memory. Are you physically running out of memories or something else going on? And I'm just bringing across, say, too wide a row of data to be able to fit in a single memory bucket. So do pay attention to that. Buffer sizing, I always like to mention this. I will preface this by saying this is one of the last settings that I will check whenever I'm doing performance tuning. Integration services, the internal engine does a pretty good job of doing automatic buffer sizing, but do know that you have some control over how to suggest a change. And again, I want to emphasize these settings, they are suggestions. SSIS will still take them under advisement, but it may still override whatever you put in. This is on a data flow by data flow basis. You can specify the buffer size or the buffer max rows. The defaults for each of those, the buffer size is 10 megs, the default buffer max rows is 10,000 rows. So the buffer size calc, and you can do this math on your own, is whatever your row size is times the estimated number of rows divided by the default max buffer row setting. So that's going to be your buffer size. Integration services will know all these except for the estimated number of rows. It doesn't have a mechanism to interrogate and say, okay, this load's going to have 37,000 rows, I'm going to size it accordingly. It will know the row size, it will know the max buffers. So this is where you could, as the developer, you could do some tweaks and try to improve that. Again, I don't recommend that if you're doing performance tuning, don't make this your first stop. Make it one of your last stops. But it is an option that you have available at the data flow level to tweak that. All right, tip number 13, the maximum insert commit size. So this is specific to the OLE-DB connection when you're writing data out to a relational database. So there's a setting that you can set, and you've probably all seen this before, that I can specify the maximum insert commit size. And you can see by default it's set to a ridiculously high number. The way that works is, and I've got a screenshot from, this is actually from Microsoft documentation, if the maximum insert commit size is greater than your buffer size, simply ignore it. That is the default behavior. Every time you get a new buffer of data, it commits that information to the relational database. You can set it to 0, and that will indicate that you want to commit not on a buffer by buffer basis, but you want to commit the entire batch or all your buffers in one big operation. This can have, so in some cases that can lead to performance improvement, but keep in mind that you could see some log growth because you're writing everything to the log as you go along and it's committing nothing until it gets to the end of it. So if you're doing a multi-million row insert, make sure that you know what's going on in your log and that you don't blow up your log there. If your insert size or your maximum insert commit size is less than your buffer size, you're going to commit more often. It will commit at the end of every buffer and every time you encounter n number of whatever the buffer size that you specify. So you might actually get more frequent updates or more frequent commits there. Note that this is completely different from the buffer size that we talked about. This will not impact the buffer sizing in any way. This only impacts how those buffers are written out to the relational database. And in most cases, just as a guideline, a small number of large commits is better than a large number of small commits because you can get less database overhead, less fragmentation with smaller number of large commits. But on the downside, you could have either log or possibly temp DB growth because you're trying to do everything at one time. All right, so nobody wants to page buffers. I told you earlier about monitoring that perfmon setting to see how many buffers you're paging to disk. But it's going to happen at some point. There are 2 settings in integration services that you can set that will specify when you write out either a buffer overflow out into disk or a blob, a large object, out to your temporary storage. It will define where those are written. So you can see the default settings are blank. Doesn't indicate anything at all. If you don't specify anything in those settings, it will write it to your Windows temp directory, which is on which disk. It's always on your C drive unless you specify otherwise. which is usually the most busy disk on your system. If you've got a disk that's not doing anything, if you've got an SSD, or if you've got some other really fast flash storage like Fusion IO, put that on the fastest storage and the least busy storage that you have available to you. Hopefully you won't use it very often, but when you do write that out, you want it to be the fastest location that you have. All right, number 15, managing your lookups. So make sure that you know the lookup cache modes. Full is default. Partial will let me, so for those who haven't dealt with the lookup transformations, full will take, like the scenario I described earlier. First thing it does is if I'm pointing to an employee table with 10,000 rows, and that's my lookup table, first thing it's going to do is go grab those 10,000 rows, put it into SSIS memory. If I'm dealing with, say, I'm Amazon.com and I've got, I don't know what they have, 10 million products or something, the first thing it will do is go out to whatever table I specify and take all 10 million rows and bring it into SSIS memory space. Do be aware of how memory is handled, how many rows that you have coming in, and all that, because your lookup cache mode can have a big impact on that. Full, again, will take all the contents of whatever the query is and put it into memory. Partial will do, it's still going to do a row-by-row lookup for every row that you encounter, but whenever it gets a new distinct value, it's going to store that in cache. So if it's looking up names and it comes to Tim Mitchell, it's going to make a round trip to the database and then store it in cache. So the next time it encounters the same Tim Mitchell name, it's not going to make that round trip. It's going to use the local copy that you have. And then finally, none, just like the name implies, doesn't put anything in cache at all. So full cache does have some benefits. If you've got a reasonably sized lookup table and a large set of data to be validated, it can be useful. The partial cache, if you've got a large lookup and a reasonable number of rows coming in from your source, if you're doing this on 1 billion rows, you probably don't want to use the partial cache because you could do literally 1 billion round trips to your database. So know how your data processes or how it performs there. No cache if you've got a small lookup table or a small number of rows coming through and you only have one hit or one match for every time that you run that operation. All right, I'm going to show you a quick demo on how the lookup behaves. So I'm going to run this. I've got on my data flow pulling in some salary information from our relational database. I'm doing a lookup on a different table using the lookup transformation. I am using the default setting here of full cache mode, and finally writing that out to a flat file. So when I run that, it's not a lot of data. It's sitting here, it's waiting, doing nothing. So, you know, that wasn't overly slow. It's only 10,000 rows of data. If I go look in the log, it took, if I look at the very bottom, it took 6 seconds for that, which is still pretty quick, but considering we're only dealing with 10,000 rows, I'm not really happy with the performance. If I start interrogating up here, I can see lookup is caching. It cached 800 rows. Now it cached 6 million rows. And the processing time for that was 5.5 seconds. So of the 6 seconds that this package ran, 5.5 of it was simply taking that data, that 6.2 million rows of data in my lookup table, and adding it to the SSIS memory. So, but once we get there, it's going to run very quickly. So once we get to this point, it's going to run those 10,000 rows through really quickly. You saw that, you know, based on just some really simple math, it's about 1/2 second to run those 10,000 rows from here to here once we've cached that information. So depending on the size of the data that we're dealing with, I can experiment with some different caching modes. So same exact scenario that we had earlier, but if I open up my lookup transformation, I'm changing this to a partial cache. So for every row of data that we get through, every distinct value that we get through, and specifically if I look on my columns tab, for every distinct social security number trying to match up to SSN on my lookup table, it's going to make a round trip to that database. Now, you might think that going row by row by row would actually be slower, but because of the configuration, the number of rows that we have on this load, it's actually a little bit faster. So we had 6 seconds earlier. To go row by row on as many as 10,000 rows of data took just a shade over 2 seconds. And if I look up here, you see on my log, I don't have a lot of that lookup overhead. So I'm preparing my cache here. Instead of having 5.5 seconds, it took me 1/1000th of a second just to prepare the cache. Now, it still does take a little while to make all those round trips to the database, and I'm making up to 10,000 round trips, but for this type of data volume, it actually ran faster to make all those round trips. If I go up to, so in this case I'm dealing with 10,000 rows of data. If that were 1,000,000 rows of data, I would bet my salary for the day that the other way would actually be faster, that the lookup by pulling in the 6,000,000 rows and then doing a set-based lookup will almost always be faster on that. So is there a magic number? Probably not. I would say if I had to throw a dart and say where the breakpoint is, I'd say about 100,000 rows. But that will vary greatly depending on the width of the data, how much data you're pulling in. Are you doing a big old select star and bringing in a whole bunch of data? Are you bringing in a wide varchar or in varchar versus a 2-byte or 4-byte integer? All those will have an impact on it. But you can see that just by changing the lookup cache mode, I can significantly impact the performance of my package. All right, so the next to last tip is sharing the road. So this really isn't an SSIS issue. It's more of an organization or an architectural thing. So know how, within your environment, know how other processes are scheduled. If you've got, say, your load window is from 2 a.m. to 6 a.m. every day, you don't want to start everything at 2 a.m. That gets into the parallel issue that I discussed earlier, where if you're running everything at one time, it's probably going to degrade your performance. But you can look at a work pile pattern where you are doing multiple operations that are unrelated to each other, as long as they're allowing sufficient room in your I/O throughput and your memory and so on, that you don't overwhelm your system. So do pay attention to how things are scheduled, because that can have a big impact. All right, last but not least, you want to look at staging your data in a lot of cases. So integration services data flow is really, really good. It will process just about anything that you want to do as far as data movement operations. The downside of using that is sometimes if I'm dealing with non-relational data, so I'm pulling in, especially if I'm pulling in flat file data, XML data, the dreaded access data, pardon me, if I'm pulling that in, I really can't do a SQL to SQL operation on that. I can't go table to table on that. I'm limited to doing it in the data flow. In many cases, I can stage that data and make that a SQL to SQL operation, as opposed to trying to do everything in the data flow. You heard me say it before, let the database engine do what it does well. This applies to inserts and deletes in many cases, but updates in particular are prone to a great deal of benefit from staging your data, and I'll show you an example of that. So I've got two different packages here that are effectively doing the same thing. So I've got one that I'm affectionately calling RBAR, and if you're a fan of SQL Server Central, there's a guy named Jeff Moden that invented a term, RBAR, and it's pronounced rebar. It's called row by agonizing row. You want to avoid row by agonizing row, and that's exactly what we're doing here, is using row by agonizing row. So I'm pulling in a flat file, and I'm using the OLEDB command. Now this is not the OLEDB destination. This is that OLEDB command that I mentioned earlier that goes row by row. So I'm doing an update operation. I'm updating the email based on a join with the phone number. Now, this might look like a set-based operation, but it's really not, because I am using the OLEDB command. If I run 10,000 rows of data through here, it's not running a 10,000 row operation. It's running 10,000 one-row operations. So let me go ahead and run that. I think we've actually got 15,000 on this sample. So it'll take the first batch of 9,900, run those. So it wasn't extraordinarily slow. It took about 5 seconds to run that. But I'm not terribly impressed with, all we're doing is pulling in data from a flat file and doing an update. I'm not overly impressed with that taking 5 seconds. So let's see if we can use an alternate pattern and improve that. So we're doing, the net effect here is that we're doing the exact same thing. I've got two different steps here instead of one. On my data flow, instead of loading that out to the OLEDB command, I'm actually loading it out to a staging table. So I'm writing that out to my staging.people table. So I'm writing that out, and then back on my control flow, once I've got that written out, I am doing a SQL to SQL operation. So I'm doing an update. I'm updating my people table based on the join against that staging table that we just populated. And from that, let me run this. So we ran about 5 seconds earlier. Well, and we don't even have time to pause here. So 5 seconds earlier, and we're at just a shade under 0.4 of a second. on that operation. Even though we do have more moving parts on that, you can see that by doing a stage operation, it improves the performance quite literally 10x by doing that. And this is the type of operation that it's not if you do a set-based SQL to SQL operation as opposed to a row by row operation, it's not going to improve your performance in a linear fashion. It will do it in an exponential fashion, where if you're doing, say, 10 times the data, you might get 100 times better performance instead of just a simple 10x performance benefit. So as we've shown, you've got a lot of different things that you can do in integration services that can help out with performance. A couple of resources that I want to point out to you, the link that I mentioned on Rob Farley's blog, if you don't catch it right now, you can come back. Again, this will be available for download. And then there is the Microsoft Data Loading Performance Guide. It's a really big, it's probably a 50-page document, but it's really good information about just general loading on integration services on the database engine as well. All right, it looks like we're right up against time. We got about 1 minute left. I'll ask Leslie if she's got any really interesting questions. I do want to encourage you, if you heard something that you want a little more information on, you got a question that maybe I left something hanging and didn't completely answer, I do encourage you to email me. I'd love to hear from you, and then you can subscribe to my newsletter as well. I send that out about every 2 weeks, and it's got various ETL and other types of information on there.
Awesome. Thanks,
All right,
Tim.
so Leslie, we've probably got time for maybe one question, I think.
So I had two questions. One was around start cataloging and what DMVs can be used to tune SSIS. So maybe you want to grab one of those.
What was the first one that you mentioned?
How to start cataloging?
How to start cataloging. So that's a good question. So I assume that the question is around using the SSIS catalog. So if you're using SQL Server 2012 or 14, the catalog is already a part of the install. It is not installed by default. I'm trying to remember. I'd written at least half a blog post about how to install the SSIS catalog. I don't know that I actually published that. But it's about a 4 or 5 step process to start using the integration services catalog, to install it, to get it up and running. And then once it's up and running, it's simply a matter of, instead of deploying packages to the MSDB like you used to do, it's a matter of deploying them into the SSIS catalog. If you're used to using MSDB to store your packages, the catalog is a lot simpler operation. It's the database is named SSISDB. It's dedicated for that process. It's much better suited for storing integration services packages, and especially in terms of things like logging, storing parameters, and other tasks of that nature. It's much better suited than using MSDB.
Yeah, I think it's really given people a quick way to get their SSIS up and running and watching it, right? With some of those
absolutely. It's a good way to centralize all your storage there.
Yeah. Okay, Thanks so much for joining us today, Tim, and doing this presentation. It's always great to hear you talk. Tim has his information up on the screen right now if you want to reach out to him for further questions. And the next Palooza session will be starting here right now. That is going into some latency on always-on groups. I did post that link on the chat window if you would like to join that. Tim, have a great day. Thanks again so much.
All right. Thanks, Leslie, and thanks, everyone. I appreciate your attendance.
Thanks.
Thanks.